Okay guys, for this video we're going to be doing 9-5, which is factoring differences of squares. And for this problem we're going to be doing number 13 on your homework. So we'll be starting with this one, number 13, which is 20q squared minus 5r. Now remember that when you see this problem, it has to be written in a squared minus b squared form, which it is. A in this case is 20q and b is 5r. The minus is not necessarily the negative of the 5, it's just part of the problem, so we're really not going to mess with it too much. So the first thing to understand here is that this is a factoring out a common factor problem, because these two numbers have a common factor, which is 5. So that's the first thing we need to do. That's our first step, is factor that out. So we're going to do that by doing all the factors of 20q squared and 5r squared. Remember, it's not negative 5r squared. That negative is the subtraction sign that links the two. So the factors of 20q squared is 2, 2, 5, which gives you 20. And then q squared is 2q's. 5r squared is 5 because it's prime. You can't find anything else. And r. So as you can see, the only thing they share is the 5. But that's okay because that's their first common factor. So you're going to bring out the 5 from this problem up here. So when you bring out the 5, it's essentially you're dividing the 5 out. So 20 divided by 5 is going to give you what's left here, which is 4q squared. The q squared stays out because they didn't have them in common. You have the subtraction sign here. And then if you take the 5 out of here, you're left with a 1 because remember, it's as dividing it out. So 5 divided by 5 is 1r squared. So now the important thing here is that you need to remember that this 5 is completely done. We'll never touch it. We'll never do anything else to it. That's going to stay as part of our problem. The only thing we're really going to focus on is what's left in here. And since this is still written in a squared minus b squared form, we can still work with it. However, as you can see, there's no more common factors in here other than 1. So we can't factor out anything other like we did up here. So when we can't factor anything out, then we need to find, we need to square root everything. So in other words, we're looking for something, two things that multiply to each other that equal 4q squared, that are equal to each other. So it's just like we're finding the square root of these two. So the square root of 2 is going to be 2. Or I'm sorry, the square root of 4 is going to be 2. And the square root of q squared is going to be q. And you have 2 of these, so that's why I put that on the outside, because whatever you have here has to equal what's in here. And 2q squared equals 4q squared. And then the subtraction sign comes down. The square root of 1 is, of course, 1. And the square root of r squared is r. And remember, you have 2 of those. That's how we got that. All right, so we're pretty much almost done. The only thing we really need to do is simplify this out. So if you remember this 5, we're done with it, so we're going to keep it there. There's 2 q's, so remember that in ab minus, or a squared minus b form, that's going to equal a minus b, or sorry, plus b, and a minus b. So here we got, in a's spot is 2q, so we have 2q plus, because that's the next one in our formula, b, which is 1, r, that's b right there. Then the next one is a, which is 2q, minus b, which is 1r. If you really want to get technical, I guess you could just take away that 1, you could just make it r. That would be fine. That works out. And that's your answer for this one. Remember that in the beginning, not all of them will be able to be factored out like 20 and 5 were. So if you don't have anything to factor, you can start by finding the square root of it. Okay, the next problem we're going to work on is number 10 on your homework. This one should have been done on Tuesday, but we're going to go over it because I think it's very important to go over it. Now, unlike the last one we just did, there's nothing we can factor out here. The factors of 4c squared are 2 times 2 times c, and the factors of 5d squared is 5 times d times d. So as you can see, we have no common factors. So factoring out this is not a question. It's not an option here in this problem. But what we can do, if we can't factor, since this falls into a squared minus b squared, which we know equals a plus b and a minus b, is because it falls into that form that even if there's no factors, we can start square rooting it. So what we're actually going to do is we're going to start square rooting them. Remember, the negative is not part of that 5. It's just there as a subtraction sign. So 2 squared, or 4 squared, is 2. C squared is C. Remember, you still want to put the power sign up there to show you that this is equal to that, which it is, minus. Now, when we get to square rooting this 5, we can easily square root the d squared, and that's going to be d. And you can start right there. But to square root the 5, you have to understand that 5 is a prime number. And because it's a prime number, that when you try to find the square of it, it's going to give you a never-ending decimal, which means that it is impossible to find the square root, to write down the square root of 5, because it keeps going over. Now, estimating is not going to help you out here, because if you estimate it to be something close, you're not going to end up with 5 at the end. So because it's a prime number, there's nothing you can do for this spot right here. Because there's nothing you can do for this spot right here, you cannot complete this problem. This is the same thing when you hit any prime number in this that you're trying to find the square root of. They will be never-ending decimals, and you cannot complete this problem. That way, your answer is unobtainable, so the book asks you to write prime. Because you're dealing with a prime number and you cannot square a prime number, at least to get the exact square root of it, your answer is then prime. This one is problem 17 on your homework. Now this one you might see is a little different because when you look at it, if you look at it just like this, it is exactly the same as all the other problems, and you should have no problem solving it, except this time it equals 0. This time we have an equation. Now first we got to check if there is a common factor between 49 and 36. There is not a common factor for 49 and 36. So once that option is done, what we need to do is find the square roots of it to simplify it. So we can find the square root of 36, which is 6. And then the square root of q2, which is q. And remember, you have to square it. You have the minus sign that comes down. Then you have the square root of 49, which is 7. Actually, that doesn't need to be in parentheses because there's nothing else next to it. Don't forget to bring down the equals 0, or else you're going to end up with the problem with an answer like the previous problems, but this time it's different because it equals 0. So from here, if we follow our formula of a squared minus b squared equals a plus b and a minus b, we know that we have an a, so we have 6q plus b, which is 7, and then we have a again, which is 6q minus, this time because of the formula, b, which is 7. And normally we'd be done if we didn't have this equals 0. Normally if it was just a problem without the equals 0, we'd be done. That's our answer. We're done. However, here it equals 0. Now because of the 0 property rule, we know that we're going to have to assume that both of these equal 0. So we're going to have to find out what each of them would equal if they were both equal to 0. So the good thing here is that it's not too difficult, and important thing to remember is to do them one at a time. So I'm going to go ahead and start with 6q plus 7, and I'm going to equal that to 0. Now, you guys should know how to do this. We have to, of course, subtract 7 because we want the q to be by itself. I'm going to go ahead and move my work over here. 6q is going to be left here. 7 minus 7 is 0, so I'm not going to leave anything there. And 0 minus 7 is negative 7. So at this point, we're going to have to divide by 6 to get q by itself. 6 divided by 6 is 1q, or just q. And then we have to divide this by 6. Now, this doesn't work out to be a perfect number, so we just like to leave it as a fraction. So 7q, or q, equals negative 7/6. So that's our first answer in our solution set, our first possible answer. Now that I've done that, I'm going to go ahead and erase this work so I can have room to do my other one. I'm going to go ahead and do this one. Now what you're going to find is because these two are the same and the only difference is that one's positive and one's negative, that you're going to get the same answer here, which is negative 7/6, except it's not going to be negative this time. So go ahead and watch. It's 6q minus 7 equals 0. Because it was positive last time, we had to subtract it, but it's negative this time, so we're going to add it. That's gone. We have 6q equals 7, positive 7. We're going to divide by 6 again. 6 divided by 6 is 1q, or 1, and then 1q is just the same as q. And divided by 6, we have 7/6. So that's what our other q equals. Okay. You can write it this way, where the solution set is negative 7/6 and then positive 7/6. Or what you can actually do is you can also write it this way, where you have a positive and a negative 7/6. That way, this tells you that the answer is both positive and negative. Okay, the last problem we're going to be doing is problem 24 on your homework if you're following along. So first thing you should know is that this problem does not equal 0. And it does not look like the a squared minus b squared format that we need to have it in. So that's what we need to turn it into. So in order to do that, we need to move this 81 first to the inside. So we're going to do that by subtracting it from the outside, putting it on the inside. We're left with 1/16y squared minus 81, and that equals 0. The next thing we're going to do is, because there's no common factors between these two, we need to start square rooting them. We need to square root both of them. I'm just going to put the square root symbol over both of them. Actually, let me do this. So 1/16. Remember, square rooting a fraction is the same thing as just regular square rooting it. Do the top first. The square root of 1 is 1. The square root of 16 is 4. The square root of y squared is y. And remember, that's to the power of 2 to make sure it's equal with that. Use the subtraction sign. Square root of 81 is 9. Make sure you put the square there to make sure that it's equal to what was on top. Now it looks like what we have here. And since the a and the b is already separated, now I can make my problem, which is going to be 1/4 y plus 9 and 1/4 y minus 9. And that is equal to 0. Normally I'd be done, but of course it's equals 0, which means I have to make sure both of these equal 0. Since the only difference between these two is positive and a negative sign, that means they're going to equal the same number, but one's going to be positive, one's going to be negative. So I'm going to go ahead and do one. That way I don't have to do both of them. As long as they're the same and the only thing that's different is the signs, they're going to equal the same thing. So I'm going to go ahead and do the addition one. So 1/4 y plus 9 equals 0. Obviously, we want to get y by itself. We want to solve for y to get our solution set. So we got to subtract 9. At this point, this goes away. We have 9 over here, so we got 1/4 y equals negative 9. Now, in order to get y away from, or 1/4 away from the y, we need to turn it into a 1, so it's 1y. Remember, we do this with a fraction by multiplying the fraction by its reciprocal. In this case, it's 4 over 1. 4 times 1 is 4, and 1 times 4 is 4. 4 over 4 is 1, so we're left with y. And then we do the same thing to the other side over here. 4 over 1. Since this isn't a fraction, this negative 9, we need to turn it into a fraction. A negative times a positive is going to give me a negative, but I know this one's going to be positive, so I'll just put a negative right now. 9 times 4 is 36. And 1 times 1 is 1. 1 goes into 36, 36 times. Now remember, this problem is the same one as this one, except instead of subtracting right here because it was positive, I need to add. So it means that this number down here is eventually going to be a positive 9, which means that this is going to be a positive 36, which means that I can just simply do this. My answer is, my solution set is positive and negative 36.